on. So today I'm going to be talking about this polymorphism, what it is, and this example is going to be a good example so we can try to understand what is this polymorphism and what's the benefit of that polymorphism and so on and so on. Yeah, so let's get started. So the first thing that I'm going to do, I just created like this project, this one, week 2, exercise 1, but I'm just going to collapse those so it's going to clearly see this one. So see, this is the class, but I'd like to make it like this test shape. I would like to have the same example, same code that I showed you here. So what I can do, I would like to change that. When you'd like to change, you just right click and then refactor, and then you rename, or you press the Control R, which was the thing that I usually do. I press Control R and then I give it a new name, and the name is test shape. So that's what I would like to use. Notice that when I put this copy and pasted, it told me that test shape is not a valid Java identifier because of the space. Because when you paste, sometimes when you copy, the space might be part of it. So just pay attention to those spaces. And then I'm going to refactor, and this does two things. First of all, it changes the class name and the file name. The file name has to change because it has to be the same as the class. And then I'm going just to copy this and paste it into the main, because that's what this is, right? I'm going to do that. But I have a lot of classes to create. I have the 3 classes, the shape, the rectangle, and the triangle. All these need to be created, but they're not here. Now I need to create them. I can do that one by one, or I can just right click, click on this one, and then look at the options. Now if you look at the options, NetBeans tries to tell you, okay, try to find the classes that are in different other packages that you can use. So for example, it says that this rectangle is in this java.awt, or this rectangle in the same name of a class but in different package, javafx, scene, shape, rectangle, etc. So they're different. It's the same name of the class, but actually it's not exactly the same class because it's different packages, so they work differently. So I don't need either of those. I would like to create a class. Now, in create a class, I have 2 options of this create a class. Create a class with a constructor. You see this java.lang.string and then int in package, or create a class in test shape. So because I can have a class inside of a class, which is a topic that we're going to be talking about later on, that's not what I would like to do. I would like to create a class in the same package, which is the package is week 2 exercise 1, because that was the original name of my project. So, and that's what I'd like to do. And by the way, it's just NetBeans have detected that this rectangle here needs a constructor that takes a string, an int, and an int. That's why it's suggested to have, it's going to create the class and the constructor at the same time. So it will help me, just instead of typing a lot of code, just do things faster. And this is what it does. But I can do this manually myself, and then everything, create a class, right click, and then create a class, and so on. I can do that. So I'm going to just delete this. I'm trying to show you that you should use the help of NetBeans, but be careful, because you might get confused and do something wrong by, for example, if you just go for the first option, you get importing, but still it doesn't work. You get a lot of problems then, no suitable constructor found, and the options are going to be not really helping again. And then if you just take the first one, it's not going to do whatever you want. So it's going to be having some kind of problems. Then you won't understand why are there the problems, because this shape is not the shape that you would like to have, it's another one. And then that's what I would like to avoid. So either you do it manually, but then be quick so you don't waste time, or you just need the help, use the help of NetBeans, but do it wisely. So for example, the first thing I'm going to do, I'm going to start with the class shape. Why? Because, well, shape is the superclass of the two, so I'd like to start with that. And I will just create a shape, create a class shape in the package week 2 exercise 1. That's what I'd like to do. And notice that if I do that, you see, there's no public or private or protected, but this is by default package. So does anything here mention what kind of access modifier the class has? No. So you can leave it as is, or you can make it public, or we can make it whatever you want. We don't care because we did not mention anything. So, but pay attention that if there's nothing, that means it means something. There's package, it means something. So I'm going to leave it as like package. I don't care for now. And in this one, I need to have a private string color. Now this string color, I would like to have a get area and a toString. Okay. First of all, well, this shape, I'm going to have to create a constructor that initializes the color. Why? Because this constructor of my subclass will need to initialize the color, because I'm giving it a color, and this one needs to go to the shape. So I need to initialize the shape somehow. So the constructor, I'm having a constructor that is going to initialize the shape. Now the getters and setters, if I need them, will I need them? Well, yes, because in my toString, I would like also to be, for example, if I'm displaying the toString of a rectangle, I'd like to see that the rectangle is red, for example, or the color of the rectangle. So I need to do that. So actually I need to have access to this, and that's what I'm going to do. Alt insert and then getters and setters for this get color and set color. Then the last thing is, I mean, not the last thing, there was one thing, the toString. The toString, I'm just going to keep it as it is. I don't need to do any change. Nothing mentioned what I should display in the toString, so I'm free to use whatever I want, and this is what I want. The last one is this, get area. Now this get area is the public because of this plus, but nothing here mentions the return type or the parameters or whatever. It just tells me this is very general. It doesn't give me a lot of details, but I have to generally a get something returns something. So what does it return? An area of a shape. What kind of data type it is? Double? Well, why double? It could be int, right? But yeah, we can have maybe a rectangle of 5.5 and 2.7, then the area should be double. So it's better to put it a double, because if you put it an int, it's not going to work out. But if you pay attention, the triangle, the area of a triangle involves 0.5 multiplied by the base and the height, multiplied by the height. And that's something that is going to be double. So let's make it double. Now get area for a rectangle or for a triangle, I know what to return. But what about the shape? A class shape is like some kind of general abstract concept of a shape. A rectangle is a shape. A triangle is a shape. A square is a shape. A circle is a shape. But if I don't know what the shape is, I cannot tell you what's the area. So what should I return now? Now I need to return something because, well, I might say 0. Okay, because I don't know what to return, I'm just going to say it's 0. Or maybe -1, because I'm saying with -1, well, this value means it doesn't make sense. A shape cannot be negative. An area cannot be negative. So when I'm getting get area of a shape, it means, okay, it doesn't make sense to have an area of a shape because I don't know what it is. Anyways, anyone can put anything, it makes sense, that makes sense to you, that's fine. Because that's not the purpose of this, exercise, to pay attention to what am I returning in this get area of the shape. But you do realize that I need to return something, and you're going to choose whatever you deem making sense, what makes sense to you. I will leave it at -1 because -1 is clearly mentioning that something is wrong. 0, someone might think, okay, 0 is really the area of something. So I'll leave it at -1. And I think I'm done with this shape.
Did you put constructor? So
That's the one. Do I have to put a no argument constructor? Based on this example, not really. But here I need to have this one. But if you add one, not a problem. It's your call. Because in this exercise, nothing is mentioning you should not or you should do, whatever. But definitively, you don't add any variables. Now that's the thing that you don't add. You can add methods if you want to, because you just add more options, more convenience. But adding a variable, you're taking some memory. Because for every object that I'm going to create from this class, now based on this, I have only one variable, one instance variable. If you add another one, every object will have 2. And that's something that's going to add up to the space that this object is going to take in the memory. So we agree, you never add unless it's absolutely necessary. You cannot live without it. Then you add it. But this is something that generally I'm not going to do that for. If I'm asking you to design a class, I'll tell you exactly these are the instance variables that I would like you to have. And you don't add any, and you don't remove any. But for the methods, it's more flexible. You can, those that are public, you don't add any other public methods. For example, here these are the 2 public methods. Well, you don't add unless you need them. They're necessary, like for example the getters. Now we need the getters. Why? Because if I'd like to display the color of a rectangle in the toString, then I need to have access to something from the superclass. And color is private, so how can I access the color while it's private? So I need it to be public. I need to have a public access to this. I need to get color. Actually, from all these, I don't really need the setter based on this example, but what I need definitively is the get color. I really need that one. Now let's continue. Now let's go back. Now this one is not in red anymore. Now the rectangle is. Let's just keep going and then create a rectangle. And this time is going to create a rectangle with the constructor. You know, I don't want to do that, and I'm going to remove the constructor anyways. Now I'm going to remove this one. Why? Because I'd like to get the help from NetBeans by having this constructor inserted that is going to initialize also the colors. But before doing that, I just would like to add the instance variables. So the rectangle have length and width. So I'm going to add private length, which is, what's the data type first?
double.
It should be double because it's more flexible. Length and then width. Then I'm going to insert the constructor. Now this time I'll be able to also initialize them and generate. But to be using this the same way, the string should be the first. So I'm just going to take this string and put it the first. And the things are going to be the same here inside. Now, do I need to do something with these, like getters and setters? Well, maybe. I don't really need that, so I'm not going to. If I need them, I'll add them. But then, for now, I don't need them. So now, just make sure that I have this constructor that is available. Now, I need to have the get area and the toString, because the toString is used here and the get area is used here. So let's do that. I'm going to have this toString because it's easier. Now this is a rectangle. I just would like to display the color of the rectangle, so I'm going to add color. And yes, now that's why this get color is going to be handy, because I need to get the color from the superclass. And then public, I can just do also alt insert, and there's some override method. and I'd like to mention that I'd like to override the get area, because now the get area of a rectangle is going to be different from a get area of a shape, because this is going to return the length multiplied by the width.
Yes, sir.
Yes.
If I create variable called result,
While you create a variable here, you mean? Inside? Yeah, you can do that, no problem. You can create in local variables, and then that's fine, because this variable that you just created, it's just going to be temporary during the execution of this method. Once the method is done, the variable is going to be freed from the memory, so it's not going to be permanent. But when you create an object of a rectangle and you add here an extra variable, every object is going to, as long as this object is in the memory, is going to take more space. So this is okay. But I don't have to, but if you do it, that's fine. Is that okay so far? Yes. I don't need, if you do that, that's fine, but I don't need them, because based on this example, I don't need them.
So if I do it, it's fine?
Yeah, that's fine. Actually, NetBeans will do it anyways, if they do it for you, so it's not a big deal to have it. But because in this exercise I don't need it, so I'm not going to use it. And I'm going to talk later about this suggestion of NetBeans. You know, whatever it's in yellow, it's a suggestion that NetBeans tells you. Pay attention. It's like a warning. Like, watch this. Maybe you should be careful about that. Now, this is something talking about field length can be final. Well, final is a keyword that does something to a variable, to a method, to a class. And we will talk about that later, inshallah. So now, the rectangle is done. If I look here now, the rectangle is not a problem anymore. Now the triangle. Now for the triangle, I just would like to show you something different that I can do, which is, triangle is mainly like a rectangle. So I'm just going to right click and copy, and then right click on this package and then paste. And refactor copy. So it will tell me, okay, what's the name of the new class? I'm going to, it's triangle. And then press enter. The name is changed. The constructor is ready. And I have everything except this should be. This is a triangle.
different instance variable.
But the name of the instance variable should be different, because this is base and height. So I'm going to change that. Base and height. All right. Now also the area is different, because it's 0.5 multiplied by these things.
The parameters of constructor.
Well, the parameters, if I leave them like this, that's still fine. But it's not a good idea, because it's going to be confusing, right? So you can use this to have the same representation. So it's going to be making more sense. Yep. And same thing here. I'm just going to make it base and height. Yes.
This is class. We can put digits behind and keep space.
If you want to, yes. But do I need it really? Based on this example, I don't really need it. But yeah, you could do that. Now what I can do, and this is something that is going to be, I don't know, an addition. I'm just going to add something else. I will add, first of all, I forgot to add a space here between these two, so I don't have things cramped up. And then here, after that, I just would like to add like the area of that rectangle or that triangle. And I'm going to do this. So if you give me, the toString is going to get the color, the base, the height, and then the area, and then close this. So I can have this get area as well. And you know what, I should have done it before because it would have been easier. And the plus is on the wrong side. So yes, like this. And then it will be straightened up.
How did you use it, add plus?
What do you mean?
How did you add plus?
Just add the plus, I did it myself. And then when I saved this, the formatting of put the plus before, and that's. So now I have my class ready, and I can just close the old ones. Now this test shape is ready to work, and if I run it now, it should not be of any problem. Now let's have fun with the polymorphism. Now, if I try to understand what happened, first of all, what I'm doing here is called I'm creating an object of rectangle, and then this rectangle I'm putting it inside of a variable s1, which is of type shape, which means what am I doing?
Print.
No. Up something? Upcasting. Because I'm putting a rectangle inside of a shape. That's normal. Well, that's okay, because I can put a rectangle inside of a shape, because a rectangle is a shape with some special things. Now, when I do this, I printed this one. That gives me this first line, right? Now I'm printing S1. S1 is a shape. But the toString that was called, was it the toString of the shape that was called?
So the rectangle.
It was the one from the rectangle. Weren't you a bit like perplexed? There is a toString into shape, right? In shape, I have a toString. Here it is. And maybe I could just do the same thing with area. I don't know. So it should be consistent. It should be here. So why, now the question, why after calling, sorry, if I come back here, why when I called this and I ran it, it called the toString of a rectangle even though S1 is a shape and I'm using S1 dot toString?
We're overriding the toString in the rectangle class.
Because we're overriding the string in the rectangle class, so that's why we're using it. But I'm calling the S1 that is shape toString. Now it would have been obvious if, for example, this was a rectangle. Now a rectangle, okay, obviously, yeah, I'm calling the toString that is of a rectangle. But if I work at a shape, I'm calling a toString of the S1, which is not a shape, but a rectangle. So even if I'm storing a rectangle object into a shape, it still remembers that it is a rectangle. So that's why when I call the methods, if the method exists in the rectangle, it will be executed. But if it doesn't, it will just not execute. Now there's one thing though that is kind of interesting, and this shows you that why we did this get area here, even though it doesn't make sense to have get area. This is not going to work for the get area if I remove this one. Now this works with the toString, this one, and it works also with the get area. toString because it's inherited even from object. Even if I don't have it, I'm going to inherit one. But get area, it's from the shape. Now let's see what happens if I remove this.
subclass.
First of all, I have errors everywhere. Why everywhere? Because it tells me, well, for this get area where I don't have it. So let's remove it. That is easy to fix. How about this one? It tells me, well, you're saying you're overriding, but there's no overriding that is happening. So it tells me that this thing, you're just mistakenly thinking that this is overriding. So, okay, let's remove this. And this is going to be fine. Do the same, and then we're fine. But this last one, you cannot get it done, because it tells you, cannot find symbol, method get area. But hold on. The toString was able to find that this S1, even it's a shape, it was executed a toString from a rectangle. Now S1 is a shape, and in the rectangle we have get area, and it's not able to find get area. How comes?
Because it didn't inherit it from the shape class.
Because it doesn't exist in this shape. When you do something like this upcasting, and you try to execute a method, you can only execute a method that also exists in the superclass, like for example the toString. Now toString exists in my superclass, so it's available, I can use it. But now a shape does not have a method called getArea. And if you try it, but my subclass has it, the subclass of shape, the rectangle has it. Now because I put a rectangle inside of a shape, and I'm calling a method that only exists inside my subclass, the rectangle, this is not going to work. You cannot do that. You can only do it if you have the same name of that same method in your superclass, this shape here, because shape can only call the methods that are available in shape. If it happens to be existing in also your subclass, the rectangle, then it will going to use it if you're doing this upcasting. But if it doesn't exist in the shape, well, you cannot use it. Yes.
So if I remove the toString in shape,
If you remove the toString in shape, but let's try that. It's kind of different. That's why I did not remove that. If you remove this, it's not a problem. Why is it not a problem? Because this toString now is not from a shape, but it is from object, and you cannot remove that one from object. So now if I run this thing, it is going to be the toString that is exactly the same thing, because I'm overriding the one not from object, not from the shape. So that's why with this toString it's not going to happen. I won't get a problem, an error message like this. But getArea does not exist in object. It does not exist in shape. It exists only in a rectangle. And you put a rectangle inside of a shape, that's fine. But you cannot call the methods from rectangle that does not exist in the shape. So when you call a method, when you do this upcasting, you can call methods and execute something from your subclass, but with one condition, that it should exist in your class. So you can call it, and then it will change the behavior of it. But if you don't have it, you cannot call it. And that's why we ended up having this getArea here, even with this value that doesn't make sense to return it. But we have to have it. If we don't have it, the rest is not going to work. Now this is telling us, well, you should better put this override, because just to make sure. If we don't put it, that's fine. It doesn't mean, well, I'm overriding this, but it just makes it clearer when you add it.
Can you
Yes.
go to class shape?
This shape.
If you rename the shape to rectangle,
Yes. Yes. Now if I rename this to
and delete
S1, now become a rectangle,
and
it doesn't relate to the shape. Now this getArea is not needed, so I can remove this safely, no problem. But now it's going to be a problem for the rest, for the others, like for this triangle and so on. But if I make a triangle, that's fine.
is there any difference?
But this one is a problem. Yes.
Is there any difference when you rename the shape to triangle?
Rename the class shape. What do you mean?
Can you go to test shape?
Okay.
Is there any difference between the shape to triangle?
Or rectangle here? What's the difference between these? Well, yes, there is a difference. Now the object itself is the difference. Now we're going to see that difference in later on. Now we're not going to be talking about this polymorphism, but now I wanted just you to realize when you do this upcasting, what I still have access to the methods from a subclass, but there's one condition: it has to be available in the superclass. Yes.
From that area.
For the area, yes.
Yeah. I do it with rectangle and triangle, but without the override.
Yes. This thing, yeah, it will work. This one,
Yes.
this is just for. It's not mandatory. If you don't have it, it's not a problem. Yeah, it's still going to work with no problems. This just mentions that it's clearly mentioned that this is overriding a method. So you just clearly mention that. It's just like some kind of making something even clearer.
But if I remove it from shape, it will be wrong.
Now this thing, this at whatever,
The
the method, yeah, the method. If you remove it, of course, yeah, it's not going to work. What is not going to work is only this line over here, because S1, even though it's inside of it is a rectangle, it's still a shape. You can only have access to methods that are in shape. So if a method does not exist in shape, you cannot have access to it. So far, so good. Just wait. Now there's something nice that I can do, and I'd like you to realize. So if you're okay with this, I'm just going to comment this and just leave it down because I don't care about this for now. And I'd like to show you something nice that I can do. You remember an array? With arrays, what one of the limitations of the arrays is that I can only put one data type in every cell, in every element of the array. If I have 1,000 elements, they all have to have the same data type. But then this is where the upcasting is kind of useful. And also with this type of using a method from my subclass is going to be useful. Now if I have a lot of different shapes, let's say I have an array of rectangles and triangles. In this case I might have also circles and whatever, any different shapes. But in this case we have only two classes, that triangle and a rectangle. I'm going to use these two. What if I have an array of different rectangles and triangles in one array? Can I have that? Well, yes, I can, because I can create an array of this data type shape. So remember how we create the array? So shape, and then give it a name. So this is my list equal new, and then I'll call it like shape like this, and then put the size like this. Now this list now is an array of shapes, but the advantage of a shape, because it has subclasses of rectangles and triangles, I can do something for list 0. This is the first element. I can make it a new rectangle. Well, new, not really needed. And I can have, now I'm initializing the first element with a rectangle, and I'm going to initialize the second element with the triangle, and so on. List 2 is another triangle, let's say. This one is green. Let's change a bit the numbers. 1, 2. And then let's add another triangle just for fun. That's list 3. And this one is going to be orange. And 3 and 4. And the last one, let's make it another rectangle. So this is 4, another rectangle. Sorry? Yellow. And this is 5, 6. So this is right, kind of nice, right? I can put now in an array of different types with one condition: all the types should have a supertype in common. And that's one way. If there's a situation when I need to have an array of different data types, that's how I can do it. This upcasting has this kind of advantage, is to allow me to put the type into another type, which is kind of convenient in this case. Now the polymorphism, when it happens. Now let me show you something actually nice. I'm going to have a for loop that's going to display the area of each one of these shapes. Now this is how I make a loop that goes for every one of the elements, and then I'm going just to display, let's say area equal, well, let's and then put list dot list I dot get area.
Why would we get
Now list dot I is going to be 0, 1, 2, 3, 4, right? And so list dot I is going to be either this one, and then this one, and then this one, which is going to be a rectangle, a triangle, etc., etc. Now if I do this get area, what is going to happen is that I am going to execute which one now? An area of what? The first one is going to be for the rectangle, then the triangle, then the triangle, then the triangle, then the rectangle. So if I run this thing, area 20, that means this 4 multiplied by 5. This is the one. Then the 10, 0.5 multiplied by this multiplied by that, which is half of the 20. So it's 10. Now this is this multiplied by this divided by 2. That gives me this one. This multiplied by this, that's 12 divided by 2. That's this one. 5 multiplied by 6. That is this one.
If you change the get area to string.
Yeah, it's going to be also nice. Now this toString here, maybe just do this. Now this toString is going to be the first one for this rectangle. Let's see it. Rectangle, triangle, 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 rectangle. Now this is polymorphism. Why is this polymorphism? What do we call it polymorphism? But it's clear with this one, because it's a method that is clearly doing, it's the same method. I'm calling the same method from a shape, but this method is going to be having different form. Polymorphism means, poly means many, morphism is something about the form. So this method that takes many forms. Get area is an area of a rectangle sometimes, a triangle sometimes, and if you imagine, I'm using also circle, square, whatever different shapes that I have, all subclasses of shape. It's going to be a lot of different kind of methods with one name I can call different methods. That's why they call it this polymorphism. So, but there's one condition to that. All this, it can be done because I'm having get area here. If I don't have get area here, I cannot do this. And that is the idea behind this polymorphism. Is the fact that you can have one method that can have many meanings, can take different forms. Now this method takes the form of a rectangle and takes the form of a triangle based on which object I'm referring to. And this does what? This relies on something called this late binding or dynamic binding, like binding, connecting things. So what happens is that this method is going to be connected to the right object when at runtime. When the computer runs, it's going to take this get area. Okay, now get area, which one should I execute? Now list what is the data type of list? List is a shape. But inside of that shape, I need to find out, okay, what's inside of it? Is it a rectangle? Then I'm going to execute get area of a rectangle. Is it a triangle? I'm going to execute for a triangle, and so on. So this connection between the method and the object is not done now at compiling time, because at compiling time nothing happens. But when I run it, then it knows that this object now is going to be inside this shape, and then get area is going to be connected to that object at that time, at runtime. That's why they call it dynamic binding or late binding. So this is not going to, this get area is not going to be connected to a get area of a rectangle until I run. But the get area for now, if I just look at when I compile, get area is basically a get area of a shape. But when I run, then it looks inside and finds that, okay, it's a rectangle. A rectangle has get area, so I'm going to use the get area from the rectangle. So this late binding this is also something that is used. Is that okay? Yes.
If you delete the get area inside the rectangle,
It's not going to work. Sorry. If I delete this, it's going to work,
print the shape.
but the area is going to be the minus one, the one from the shape. So it's -1. So let's see that. That's a good example. If I'm going to remove the one from the rectangle, and if I run, everything looks fine, but all the rectangles have -1 as an area.
So it's like
Yes.
the default, right?
Exactly, it becomes like a default. Yeah, true. In this case, yes. Is that okay?
And for the list, can I make it one for the shape? Or
If you want to, yes, that's a good question. I can, for example, have this to be a shape, and the shape only has a color, so I can do something like this. Now, if I run, this one is going to be -1. Is that okay? So that is polymorphism. It's just like a big word that says that there's a method that can take multiple forms, and that's the idea behind that. Now, this same example that we had before, this method get area, actually it's an area of a shape, but it can take another area based on what's inside of that shape, and it makes it's much clearer with this example here, I think. Yes.
If the area public, how can I print?
If the area is public,
Yes.
what do you mean? If the area is public,
Without, we can print without get access, right?
the get area, you mean? Yeah, the get area is public. Yes, that's why you can have access to it.
Very much get area is private, right?
No, the get area is public. And actually, if it's private, you cannot access it outside of the class, so it's not going to be possible. So this whole thing means that this should be public. If they are not public, they should be available. Because if they're private, of course you cannot call the method that is private. So it's not going to work. Like if I do this inside of rectangle and I make it private. First of all, it doesn't work. You remember why?
Yeah, because from public to private to be error.
You cannot be
Cannot
more restrictive from something that you inherit that was open. It was public, you cannot inherit it and make it private. But the other way around is possible. But imagine this was private. Now this, it tells you, well, you cannot override this. There's no overriding that's happening because you cannot inherit. There's no available get area for you to inherit, so you can change it and override it. So that's why this overriding is not really overriding. It's just like a new method. Then you can make it private if you want. But this creates other problems somewhere else. So this here isn't going to be available because it tells you, well, get area has private access in shape. So this is private. So even though this one is public, even this is public inside the rectangle, you still cannot use it because we're still in a shape. And a shape, and in shape, get area is private. So you cannot use it. outside of the class, because here I'm outside of shape. In test shape, I'm outside of shape, so I cannot use that. So it really has to be public, or it has to be non-private, because it could be protected or packaged, and it should be fine. Is that okay? Now, this is a good example of polymorphism, but also this is a good example of something more, something that I'd like to use to introduce the next topic, which is the abstract class, and then you can take a break. So this thing here is this get area of this. You remember we had to choose, return something, because we need to have this get area inside of the shape. We need to, because we would like to be able to have this kind of behavior and to be able to call this. But if I remove this one, it's not going to be happening, so I cannot have this get area. So what to do? I need this get area. But I don't want to put a code in it, because it doesn't make sense to put return -1. And that's the introduction to the abstract class. An abstract class is a class where I can do something like this. What is this? I have a method, but no definition, no body. Just the header, the method heading, and the semicolon. That's it. Which means what this says, in this class shape, I have defined a lot of things, but this one, I'm not going to define it. I don't want to define it. But I want those that are going to inherit from me, they will have to define it. They will have to have something called get area. And now this is going to be a little bit weird. And there's a problem. So how can it says missing method body or declare abstract. And that's what I'm going to do. I'm going to make the class abstract. What does mean abstract? An abstract class means it's a class that can have abstract methods. But I cannot just leave it like this. It's abstract methods in a method that does not have any code in it. It just means that I want this method to exist in all my subclasses. So I'm forcing my subclasses to have a specific method, a specific signature, by doing something like this. But it says there's a problem, but the problem is that I need to mention this clearly, that this is abstract. I'm not just it's not like something I forgot. This is an abstract method. It's a method that has a name, a return type, and access modifier, but it does not have any definition in it, any code in it. What does this do? It forces all my subclasses. Now if I'm having a subclass of this, if I don't have this get area in a rectangle, it will tell me no, you can't, because you're inheriting from shape. You have to have an implementation of all the abstract methods from shape, or become abstract yourself, but that's another discussion. So I need to, now what I'm doing, by doing this, making it abstract and having an abstract method, I'm forcing my subclasses to implement a specific method. So they have to have it. If they don't have it, it's not going to work. Java is not going to let them go. It's a compilation error. They're not going to be able to run. So the ability of forcing my subclasses to have a specific method is done through this abstract class. However, there's one drawback. When you define a class as abstract, you cannot create an object from that class. Like, for example, you see, this is my class shape. First of all, it is abstract, right? And then it has a method that is abstract. Actually, if I just make it abstract and that's it, it's not going to work, because shape has to be abstract. If you have an abstract method, the class should have an abstract. So I want this method not to have any code in it, but I just would like to have the subclasses to implement it. Then I'm going to make it abstract, and because it's abstract, the class will be abstract. But then if I have this, if I go back to the test, all of them are okay except this one. Why? Because this shape is abstract. It doesn't have, one of the methods doesn't have a code. You cannot create an object from a method that does not have a code in one of the methods. You cannot create an object from a class that one of its methods is incomplete. It does not have any code. So that's why when it's abstract, you cannot instantiate it. You cannot create an instance of this class. But you can use it the same way that I used to do, but you cannot create an object from this class. So this not available anymore. So what I'm going to do, I'm going just to revert back to how it was. It was like a triangle. So it's going to be fine. Now I want you to realize one thing, that if now I'm inheriting from shape, I have an error message if I don't have the get area. Why? Because the get area is something that now is forced to be defined by the subclasses of this shape. Or I have another option. As a rectangle, I have two options. When I'm inheriting an abstract class, I have two options. Either I implement all the abstract methods, or I become abstract myself. Which means, okay, I don't want to implement get area. I'm not going to be able to generate any instance from this class. So I will have to make it abstract. So I have the option either to make the class abstract and then no one can instantiate from this, or implement all these abstract methods. And that's what I'll need to do. I'm going to implement the abstract method, which is this get area, and that's going to be considered like overriding, because I have some kind of a get area but it doesn't have any code in it. I'm changing it to have this kind of code that I would like to have. But actually I'm going just to bring it back how it was and bring it like this. And this is an abstract class, an abstract method. So the advantage is, what's the advantage? Well, it does not make sense to put some code just to put some code. It makes more readable to understand that this is not something that I need to put into a shape. A shape is something that I'm not going to use directly. It's used because it's going to be used by its subclasses. So this get area, instead of me putting the return -1 or return 0 or some kind of value that makes sense to me to explain, because I have to return a value, I'm just putting something that tells me, well, my subclasses will have to implement this method, but I'm not going to. But once I do that, the class becomes abstract, which means I cannot instantiate it. And once I do that, it means that my subclasses will have to implement this method, or if they don't want to, my subclasses will have to be abstract as well. So when you inherit from an abstract class, you have two options. Either you become abstract yourself, or you implement all the abstract methods.
Can you implement all methods?
Well, by just having, this is an implementation of the abstract method. So the shape, notice now the color of the shape has changed. This icon here is different from this one. Just to show this is an abstract one, this is, you can create objects, you cannot create objects from this one, but you can from this one. That's the difference between the two, so you can distinguish between them. This is an abstract class. This is the opposite of an abstract class, is called the concrete class. Concrete, I don't know, an abstract. Something that is abstract is not really tangible, something like that. I don't know. They came up with the name like that. Yes. If you want, you can.
So if I just want to write a code
Yeah,
domains, right?
exactly.
So I make an abstract, so it must be a truck or a person, right?
A truck or a person, you confuse me because a truck and a person are kind of different. So the truck and the person is not really the same I mean relationship that they have, because truck is inheriting from vehicle, right? You're referring to this exercise, right? When we had, okay, was it this one? When we had the truck that inherits from a vehicle, but a vehicle is using a person as an owner. Now, which one is going to be like abstract? The class or the method? The vehicle, the whole class become abstract? Okay, so you can make the class abstract because a vehicle maybe is like some kind of it's a general concept, but the truck is maybe more specific, and you would like to work only with the specific. Now you can make this to be abstract, even though it does not have any abstract methods. But hold on, if you make it abstract, now something is going to happen is that you cannot create an instance of a vehicle because it's abstract, so you cannot create it, even if it does not have any abstract methods in it. But because you mentioned it to be abstract means you don't allow creating objects from that class. So this is your decision. But let's say you don't, you would like to have another thing inside, maybe a method that is going to be abstract. Which one? Which one? Number of cylinders. Which one gets number of cylinders? Sets this one. Well, this is going to be okay. Now, this get number of cylinders is not a good abstract method because it's a getter. So if you make it abstract, let's say I'm going to make it abstract. I'm going to do abstract. So abstract comes before the return type and after the access modifier. So now this get number of cylinders is needed to be implemented here. So now this is going to ask me, well, implement all abstract methods. I have only one abstract method, so get cylinder. So if I click on it, it's just going to create this get number of cylinders that I need to put the code in it. So now it's me who has to put a code. Okay, but what code is going to be put in there? I can't have access now to my superclasses instance variable get number of cylinders. Or maybe what I could do, and this is maybe a good example for making this number of cylinders protected. Now if I make it protected means if I'm inheriting from a class, it becomes like public, so I can do something like this. Inside the truck. Okay, what am I doing this? But anyway, we're just practicing this this thing. But notice that this number of cylinders is protected, and because I'm inheriting from vehicle, so protected is package plus inheritance, so I can have access to it. Get what? This one? You can. What do you mean get number of cylinders? You would like to do this? But this, what's the code of? You would like to make it private? If it was private, okay, let's go back and make it back to private. Now, this is not okay anymore. Get number of cylinders. Now you have a problem. Which one is it? This is going to call the same method this one. So it's some kind of a loop. This calls this one, and this one calls this one. This one calls itself. This one calls itself. So it's some kind of a loop, an infinite loop. But maybe what you want, call the one from the superclass. So you can do this. But the problem, this is an abstract method. You cannot call an abstract method. There's no code in it. So it has to be yes. Yes. but this is just to so I mean to show another example, but it doesn't. I don't want it to be. Where is this abstract? Yes. Yes, sure. That's going to bring back how it was. Yes. This is still abstract. Yes. What's your question?
So you said the method, if it's abstract, you should create. You should put abstract in the class also.
Yes. If you have in a class one abstract method, by default, the class itself, the complete class, should become abstract.
If it's the opposite, if the class abstract.
If the class is abstract, I don't have to have, for example, see a rectangle. It does not have any abstract method, right? I can make the class abstract, but then it has another meaning, which means I'm not making this abstract because I want to implement some abstract methods. I'm making this abstract because I don't want anyone to create objects from this class. So I don't want them to create objects from this class. If they want to use this class, they should inherit from it and then create objects from it. That's the main use of abstract without having an abstract method. You don't want to have an instance from this class. So that's how you prevent that, by putting the abstract. But if you have an abstract method, the class has to be abstract.
Can you explain the abstract? The abstract, I know the abstract is the method that has not body.
Yes. Abstract method means a method that does not have any body. Yeah, an abstract class is a class that either it has one abstract method or many,
So if
or it's a class that you don't want to instantiate from it and doesn't have any instance
so if you inherit a
abstract
rectangle,
methods.
If you inherit rectangle to extend the shape, if the shape has the abstract,
Yes.
you can use the method inside the rectangle.
Which method? For example, get area.
In shape, yes, get area.
Now get area. If
Have
we,
a shape. Shape have abstract.
so shape is abstract.
Right.
Now I don't have get area here.
Yes.
You want me to remove it? You want me to keep it?
Yes.
And then the question is
The get area is abstract.
this one as well.
Abstract.
But this is not abstract. This is abstract in shape.
No, I mean in shape. In shape become abstract.
No, in the shape it is abstract already. So
How
this
can I can use get area from
in the rectangle.
yes.
Well, because get area of the rectangle, you remember the exercise that we did before. When I have something like this, because I have a get area inside of a rectangle that is defined, it will use the one inside the rectangle.
It's the same.
No, it's not the same.
If the method have abstract or not, you can use it.
Exactly, exactly. But the only difference now, I don't need to put some code that doesn't make sense to me.
Just delete the method.
Yeah. But it's the same. Yeah, it's the same work. But the only advantage is that I don't need to put some code when I don't need to, because I don't want to. And now I'm forced to put some code because of how it works. But now with abstract, I learned that I can have something that will allow me not to put some code. Is that okay? Now to practice this, there's an exercise that I would like you to do, which is this one here. It's taken from this website, but you can have a look at it. I think. No, there's others. This one is taken from other places. Now, what I'd like you to do, if you click on this one, it's just going to enlarge. I'd like you to create these classes. Now, these classes, as you can see, this shape now, this is a new shape. This one is abstract. And you know, notice now, here I'm giving you all the details. I'm telling you what's the data type and so on. Notice the new introduction of this new thing. This means protected. If there's nothing, it means package. If there's a plus, public. Minus, private. Now this hashtag or the sharp, I don't know what you call it. This hash key, this tag, whatever, is for the protected. And now, if I want you to have a method I explicitly mention it. And notice something, these ones are bold and italic, these two. This means these are abstract. Abstract methods are going to be italic and bold, and this is something that I'm overriding because that's why it's bold. So I would like you to create these classes. The circle is inheriting from a shape, the rectangle is inheriting from a shape. Notice the square. The square is inheriting from a rectangle that inherits from a shape, but the square does not have any instance variables, but it will have to do some kind of changes here. The set width and set length, they are overridden. I'm overriding these two because I would like them to change, and you have to just think about it to find out why. But start with these two after creating the shape, which is abstract, and then with these abstract methods. So you need to pay attention because it's not really that clear. It's in italic, but it's not really clearly that it's in italic. You have to pay attention to this detail, and whatever it's italic, a method that is italic means it is abstract. So I'd like you to do that, please.